Okay, here we go. This is question number 7 from our Shadow 2018 paper 2. And it goes as follows. Solve between 0 and pi over 2. So that's quite narrow, isn't it? This equation, so CSC is going to mean cosec. And then we've got this other one underneath, which might be connected. It might not. It's kind of hard to tell at the moment. So let's do this one here first. So let's just write it out. So we're going to, now cosec is 1 over sine. So it looks like I've got this one here. Yeah. So what might be a good first step is what I want to think about to begin with. So I think we're going to multiply this one up and then say 3 sine x cos x equals 1. Now, the numbers, we could even kind of swap those. However, we need to have a think about how we're going to handle this. It's not obvious, I would say. So we want to be thinking about our trig rules. So there is a trig rule that may be useful for us, which is as follows. So sine 2x is the same as 2 sine x cos x. Now, this bit is quite similar, isn't it? So if I divided by both sides, a half, that now matches what I've got, doesn't it? And what's nice about having this bit here is it's got just one trig function that I can see. So I think that's what I'm going to do. So I'm going to sub that in and I'm going to say, what was it? A half sine 2x. And then that's going to be equal to a third. Okay, let's carry on. So multiply by 2 on both sides. So we're going to say sine of 2x equals 2/3. And I seem to remember we were solving for quite a narrow domain here. Yeah. So one trick that you can do, because we've got 2x and this has x here, is you can adjust this and you can say for 2x. What this does is it just tells you where you're looking for when you solve. Okay. So let's do that now. So we're going to do inverse sine on both sides, which would give us 2x equals inverse sine of 2/3. So are we in radians? I seem to remember we were in radians. Yeah. So let's just turn this one on, check that I'm in radians, which I am. Okay. So what are we doing? 2/3. Okay, so for this one here, I get 2x equals, so I'm just writing what the value of this actually is, okay? So this is 0 decimal places, doesn't say, so just lots. So 0.7, let's go 0. I'll write quite a few. So 0.7297 is what the value of 2x is. Now, this is called the principal value. So do I need its partner value? What do I mean by that? I mean, when you have a sine graph, this is your principal value, okay? This is your partner value. Do I need this one here? Well, if I wanted to get that value, the rule for sine is that I do pi minus, or 180 minus. So if I did that, well, pi is about 3, isn't it? 3 take away 0.7. Can you see that it's... Oh, it is actually, isn't it? It is part of what I want to look at. So I think I need to write that one down. Let's write that one down just in case. I might actually not need to do this. So what I'm going to do is I'm going to do pi minus, and then when I've got all of the values that I need, I'll divide by 2. Okay. So because I have it typed in already, I'm writing this one down. So 0.36. I've got 0.365. Written down for radians. And then the other one, so if I multiply it back up by 2, if I do pi minus my answer, I get 2.4, sorry, that's in the wrong place. I get 2.4, and I was giving how many decimal places here? 4. 119. And then I would divide this one by 2. So I would get 1.206. Okay, so I'm going to write in both the 3 decimal places. So let me just check I've answered the question. So I'm looking for x values between 0 and pi over 2. So pi over 2, yeah, well, this one actually does fit inside, doesn't it? So sometimes if you're not sure, it's a nice idea actually just to do at least these two and maybe a couple of more before, because it's quite quick to do them on your calculator. Or as you saw there, I wrote that one and that saved me a little bit of time from having to go backwards. But those are my two solutions for part A. Okay. Now, what's the second one all about? So do I notice any connection between this one and the one above? My first instinct is no, I don't. Yeah, I don't think I can spot anything. But there is sort of something that I'm going to need to do to handle this one here, because this is not the nicest thing in the world to solve. So what I'm going to do is I'm going to do something with that bit there, and I'm going to leave the 2 alone for a while. So the issue here is if I divided everything by sine or cos, it would deal with these bits, but then there would just be a problem over here. So I need to change the way that I'm expressing it. In fact, if I wrote this below, I wonder if this would ring any bells of any other topics that it looks like. So I noticed that it looks a little bit like the addition rule. In fact, it looks a little bit like the sine addition rule. That's probably the one that I would use. So I'm going to express this in the form r sine, because there's a minus there, I'm going to express it in this form here. Okay? And then when I do that, you're going to find that this thing here is much, much easier to solve. So let's do that first. So if I'm doing r sine theta, so r, I'm going to write it as r cos alpha sine theta minus r sine alpha cos theta. So why am I doing it like this? Well, hopefully now you can see that these bits line up, these bits line up, so we're kind of getting some equations from this. These bits must be equal, and those bits must be equal. Notice the signs match up, so you don't need to complicate anything on that front. Okay, so let's write some equations. We're going to say that r sine alpha is 3, r cos alpha is 4. If I divide the top equation by the bottom one, I've got tan alpha equals 3/4. Okay, and I'm making sure that I'm in radians mode. So alpha is going to be inverse tan. So inverse tan of 3/4. And I get 0.6. Does it say anything about decimal places? 1 at the end. Let's just go for a good level of accuracy here. So I feel like 6,435. There we go. That's what I'm going to go with. And then the R value you get just from sort of doing Pythagoras. So R is just 5, okay? Because 3 squared plus 4 squared and then square rooted is 5. So now I've done that, what I'm going to do is I'm going to rewrite that bit there. So I'm going to rewrite that now, and I'm going to say that this is the same as 5 sine theta minus 0.6435 equals 2. We get the sine bit on its own, so we say sine theta minus 0.6435 equals 0.4. And then we're sort of back to where we were over here, no? We're back to our solving step, and we're going to go through the usual stages. It's just a regular sine. It's not sine 2x, and it's between 0 and 360. Interesting that that's got that in degrees, even though we're working in radians. That is a bit strange. How do I want to handle that then? I think I'm just going to solve it in... I think I'm actually just going to solve this one in radians, okay? And then we can just quickly talk about how you would convert it at the end. So I don't think a question would actually make you jump around between radians and degrees quite like that. but let's just answer that one there. So first of all, we're going to do inverse sine of, is that 0.4? Yep. So inverse sine of 0.4 gives me 0.412. Let's go 0.412. So theta minus 0.6435 equals, am I being consistent with my decimal places? Well, all it does is it says I have to do one decimal place at the end. So if I go overboard, that's totally fine. It's better to do more rather than less. So 115. Yep. And then it's between 0 and 360 with a regular sine graph. So, you know, I'd be thinking about two solutions from that part there. I've already got one, so I need the partner value. So this is a bit like we did on the other one as well. So how would I get the other one? To get the other one, I would do pi minus that answer. So pi minus my answer is 2.730. 2.701. 4. Okay, and then the final bit on this one is you just add this number back. Okay, so equals, you know, plus 0.6435. So that's, this final one here is going to be 3374. And is there a quick way on my calculator of going back here? If I could do that, then I could do pi minus the answer. And then I could do my answer plus 0.6435. So I get 1.055. Now, let's just take a quick look at our answer here. So it said in this one, didn't it? It said that I was looking for answers between 0 and 360. So this is actually bigger than pi. So that one actually won't be allowed in the end, will it? So that's because everything's been shifted. I just want to do a little bit of thinking a second about if I've got any new answers. So it was minus, so the whole curve moved to the right. How did I get pi minus for that one there? That value doesn't make sense, does it? No. Okay, I'm second guessing myself. Sorry, I'm thinking about 2 pi, aren't I? So actually, that value there is included. I'm just checking my answer because I'm expecting that I have 2 answers. So that's what's going on there. Anyway, these are our answers in radians. So if we wanted to do a final step, we could convert them. So the way we could convert them is by just thinking that pi radians is the same as 180 degrees, isn't it? So I've got radians. Say I didn't want the radians anymore and I wanted degrees, what would I need to do? Well, I need to get rid of the radians bit. So I kind of think of it like this. And then I need to increase the number because there's like one radian to 180. So I would multiply them by this amount here. So that's the conversion that I would do. So if I multiply this by 180 over pi, I get 60.4 for this one here. 60.44. So it's set to one decimal place. I actually get 60.5. And then my other one here, this will be 33. This will be 33. Not 33. 3.374 times the same number, and I get 193.3 degrees. Okay, so like I said, that one's a bit weird there, the jumping around with radians and degrees, which I don't think they would normally do. But it gives us an opportunity to talk about how you do it and how you can remember it. And then we also talked about the idea here, because it was sort of sine at the end, I was expecting 2 solutions. So just checking over your work. Yeah, there we go. 2 sort of not obvious cases of solving with trigonometry.